A stone is thrown vertically downwards from the top of a cliff with an initial velocity of 1 meters per second. So I'm going to draw sort of like a cliff face here. Okay, it's going to be perfectly vertical. So this stone starts at the top, doesn't it? Okay, and it's thrown downwards. Okay, so it's not like released. If it was released, it would like have a starting speed of 0. But if it's thrown downwards, it's got like an initial velocity, not of 0. In this case, it says 1, right? And it says then it hits the sea 2.5 seconds later. So it gets here when t equals to 2.5. Okay. What else do we know? Well, that's it, isn't it? The only other thing we know then is, of course, acceleration of the object, because it's falling under gravity. Okay, the acceleration will equal to 9.8. Okay, and if we take downwards as positive, and I'm taking downwards as positive because everything's happening downwards, isn't it? Or more precisely, the stone, its first movement is downwards. So whatever the first movement of the stone, if it's downwards, okay, that's positive. If it was thrown upwards, I would take upwards as positive if it was thrown upwards, even though it's going to end up falling. Okay, once it reaches its max height, it'll end up falling. If it was going upwards, I would take upwards as positive. But here, it's thrown downwards, so downwards is positive. What that allows me to do is to take acceleration then to be positive, because acceleration acts in this direction. Okay, so in positive direction is what acceleration is going in, so it's positive 9.8. So in part A, it says find the speed with which the stone hits the sea. So we want v, yes? We know u is 1, we know t is 2.5, we know a is 9.8, and we want v. So quite simply then using v equals u plus at. Okay, so v will equal to 1, okay, plus 9.8 for a, and then t is 2.5. Okay, so if we do all that on my calculator, it comes out to be 25.5 meters per second. Okay, that's the speed at which it hits the sea. Part B then, it says calculate the height of the cliff. So in this case then we want S, yeah? Okay, we want S. And we know U, we know T, we know A. We also know V now, okay? However, if we can avoid using V, avoid using it. Because we might have made a mistake there with V. Okay, that could be wrong. So try not to use it unless we have to. In fact, we don't need to though, because we've got U, we've got T, we've got A. We can use S equals ut plus half at squared. Okay, so S will equal u, which is 1, t, which is 2.5, a, which is 9.8, and t again 2.5, and we've got to square that then. So it's the case then of putting all that into my calculator. Okay, and we'll get out our answer to be, well, we've done this right, 33.125, and that's measuring meters, yeah?